Okay, so we start, I guess?
I think.
Okay, so this is JustFootball's journey to gRPC and Linkerd in production. If you skip the next slide.
Yep.
So I'm Ben. I used to be the CTO of JustFootball, and when this talk got approved, I still was. And then in the distance between that talk and now, I accepted a job at Spotify, so I now work there instead. But none of the content in this talk made me leave JustFootball, so you're still going to learn a lot of stuff that's still relevant. Yeah. Cool.
And I'm Kevin Lingerfelt. I work for Buoyant. I've been there for about 4 years, and I am a core contributor to Linkerd. Prior to Buoyant, I was working at Twitter for 5 years, sort of took part in ripping apart a giant monolithic application and converting it to microservices. So I'm very familiar with JustFootball's story as well. I'm really excited to be speaking with Ben, and he's going to kick it off with talking about JustFootball.
Yeah. Maybe if I do the slides, it might be easier if I skip through.
Oh, yeah. Okay.
So before I get started about JustFootball, just kind of like a show of hands, how many people are using Kubernetes in production today? Okay, fair few. What about gRPC? Interesting. Okay, Linkerd?
Yeah.
Nice. A few. Cool. Okay, so let's get started about JustFootball. I'm not going to talk too much about the product itself, like what it does, but we were a startup founded in 2016. We were based in Sweden. And we were an app basically designed to get kids into football. So if you skip to the next slide. So this is what it used to look like. So it was like a front-end game, I guess. Android and iOS. We used to do a load of challenges. The idea is like it's Pokemon Go for football. So you go to a pitch, you check into the pitch with your friends, you challenge each other, and then we give you some points. There's leaderboards and coin rewards, stuff like that. We also do some cool stuff with like AR, so we could basically track a ball on a football field kicked by your friends, measure how fast it went. We could do like fake goalkeepers, so you had to beat the goalkeeper and stuff like that. So there's a lot of cool challenges to solve to try and get the kids out playing football. Next. So this is what our tech stack looked like. So for a startup using Kubernetes, that was pretty fun. We had a lot of Node, React Native, we were running everything on AWS, we had bits of Go, we were using GraphQL for quite a while. So before I kind of get into like why we chose gRPC, I need to kind of go through the monolith to microservices story. So in 2016, this is what our, apologies for the terrible diagram, but this is what our stack used to look like. So we have the React Native front end just calling our GraphQL monolith, which means that all the business logic for the app was in GraphQL, like it was just dumped in there. And then we had one big, massive database at the end. So this was 2016. This worked kind of fine for us. And then by the time we proved that it all worked, we wanted to split things out and make things a little bit easier to build on. Like when you've got a monolith, everything just kind of push it, and then it becomes really hard to maintain and build on. So by 2018, this is what we moved to. So we still had GraphQL in there, but like it became a composition layer. Like it would call out to many, many services, aggregate the responses together, and then send that back to the client. And then obviously we split apart the databases, they became smaller and belong with the service. Now, this was great until things started to break. So the thing is like, building a lot of services and putting them behind GraphQL is great for splitting apart your monolith, but not so great in terms of performance. So what we found is that under load, under pressure, GraphQL would just drop connections to any service inside our stack. So remember that one GraphQL call might call 80 different services inside our stack. That's a lot of overhead of creating CPU, creating connections to other services internally. So we kind of had a lot of thought about how do we fix this, and then we settled on using gRPC. So gRPC, for people that haven't heard, if you skip to the next, it's based on HTTP2. It has this protobuf kind of schema to define inputs and outputs of functions, which supports multiplexing, and for us, the most important thing was that it supported one connection per service, so that we could just basically not have to deal with the overhead of kind of having all these different connections created by GraphQL. So this was another main reason that we switched from HTTP and REST, is because no one could ever decide how to build REST APIs inside JustFootball. So we'd spend days arguing about whether we should pass stuff in the URL, or we should pass it in the post body, and we could never agree on this. So if you imagine here, you can see these are, if you say that these are real life calls, like in the first bit, we have the user ID being passed in through the URL, and then the second bit is passed in through the post body. You've got different variables everywhere. Next. So this is what gRPC makes us do. It forces us to define our inputs and outputs up front. So you can see that we have this edit function, which takes in types of edit user requests, which is an ID and a username, and then it returns a user response, so it's all typed, basically. It gives you type-ins around your inputs and outputs. So how we did gRPC at JustFootball. So we didn't have a mono repo either. So we had like, I don't know, say 30 services that were all in different repositories in GitHub. So they were all over the place. And the protobus lived with the service. So the service defined its gRPC schema, and it lived in the same repository. I hear a lot of people like around places saying that managing gRPC schemas is super hard. So we think that we can come up with a nice way to do this, which is to publish the gRPC service definition, or the protobuf schema, with the language that you're using. So whether that is NPM, whether that's Ruby gems, whether that's GitHub for Go, whether that's whatever, is to publish it to the native ecosystem. Because that's really good at managing dependencies, right? So if we want to do like nested protobuf schemas, so you can include schemas everywhere, then let's let the package manager deal with that. Like, let's use a package manager for what it's for. If you want to know more about that, come talk to me then, and we can go through a little bit. And then also, yeah, we used to write our own TypeScript definitions too. So TypeScript was kind of early support for gRPC, I think, when we were generating clients. So we ended up handwriting our own types for everything, which was kind of a pain. But now there is support for it, I think. Yeah, so gRPC was not a silver bullet for us. Like, it still caused a lot of problems. So one was that we still have no idea what's going on inside the system at all. Like, developers creating new services every day, like we were shipping features every week. Like, we still want to push new stuff to kids and get them to test new stuff, which means building new features, which means that the system grows out of hand pretty quickly. And we have no idea what talks to what at any point. So that's kind of hard to understand. And then we also found another problem with gRPC. Because it's connection level load balancing, we have a real problem then when we want to add more pods or whatever to the new services to scale them out, because they're never going to get traffic, because your GraphQL instance, in our case, is just connected to that one gRPC pod, and it's never going to change. So how do we load balance this? How do we load balance this? And this is why we then chose Linkerd. So I'm going to hand over to Kevin now to talk a little bit more about Linkerd.
Cool. Yeah, thanks, Ben. Yeah, so let's just jump right into it. I'm going to give a quick overview of what Linkerd is and then how it can really help when you're using gRPC. Let's see. Here we go. So yeah, Linkerd is a service mesh CNCF project. It has sort of three pillars that it really tries to help your application developers with. One is observability, one is reliability, and the last is security. And I will talk a little bit about its architecture to see how it accomplishes all three of those. So we typically talk about the data plane and the control plane when we're talking about Linkerd. The data plane is sort of where your applications are running, and we leverage the Kubernetes pod model to add a proxy in the pod where your application is running, and then we reroute all the traffic to and from the pod through the proxy. And then at that point, that gives us a lot of advanced features that we can use once the proxy is routing all traffic. Separately, in a different namespace, you'll be running a control plane, and the control plane is sort of where all the configuration and metrics collection is happening for the whole cluster, and all the proxies are connected back to the control plane via gRPC, actually. And so they're getting routing information from the control plane on a gRPC stream, and then we have a Prometheus instance that's scraping all the proxies and pulling in all the request data. So by virtue of sending all your traffic through the proxies, you get very good uniform visibility across all of your applications. Now, by default, we will TLS all of the connections between proxies as well. And you can apply client policy like retries and timeouts, that kind of thing. Yeah, so specifically with regards to gRPC, you get a couple really great things. And the first is load balancing, like Ben mentioned. So since gRPC is built on HTTP2 and HTTP2 is multiplexed, basically all traffic will flow on one connection. And so when you connect to a backend with multiple replicas, like basically as soon as the first connection is established, that's the connection that's used forever, and requests aren't really balanced. So you need an application-aware load balancer, one that sort of knows the traffic that's flowing on the connections in order to fan out to all the backends. And so that's exactly what Linkerd does. Linkerd does request-level load balancing rather than connection-level load balancing. And in this way, it can really distribute the traffic across all of your backends evenly. And also, Linkerd uses a pretty sophisticated load balancing algorithm based on perceived latency to all the backends. So you'll get very even distribution of requests as well. Let's see, and then like I said, once all the traffic is flowing through the Linkerd proxies, you get really good observability. And yeah, and so we were talking about a lower level proxy, like a TCP proxy. You might really only get sort of bytes in and bytes out and number of connections, but since we're introspecting the traffic on the connections, we can give you a lot more detail, like number of requests and responses. And with gRPC, we can actually give you more structured data about the individual endpoints. So if you have a given gRPC backend that has 10 different endpoints, you can actually just pipe your protobuf file directly into Linkerd, and then Linkerd can start reporting on all of the endpoints for the service separately. So you can see the success rate of like your get endpoints versus your create endpoints. And sometimes, you know, if the endpoints have really disparate levels of traffic, a failure of one of the endpoints might get lost in the noise. But breaking it out by endpoint is like really a better way to slice and dice it. You know, so you can see here, this is Linkerd output, but you would kind of be able to see that a single endpoint is failing, whereas everything else looks really healthy. Let's see, and then the third thing that Linkerd can really help with if you're using gRPC is this idea of centralized client configuration. So gRPC has the same deficiency of every protocol, and I would call it the service owner's dilemma. And it's basically you don't really have control over who's calling your service. So if I'm a service owner, and if it's a REST service or a gRPC backend or anything, the sort of callers of your service can configure their clients in like really weird and wacky ways, and that can cause problems for your service. It can like wake you up in the middle of the night. Like when I was at Twitter, I was working on the tweet service. It turns out lots of applications within Twitter's architecture need tweets, and they would request them in very weird ways, sometimes with like really aggressive timeouts and really high retry budgets, and that would cause like a cascade of requests when we started to slow down, and that was never good. So with Linkerd, we have service profiles, so you can basically create it's a one-to-one mapping with Kubernetes services. So you create a profile for your Kubernetes service, and in the profile you can specify the client policy that you expect callers to use, and then the clients would sort of defer creating their policy to Linkerd, and then Linkerd would use the correct policy. So you can set timeout and a retry budget and that kind of thing there, and it sort of mitigates a lot of the more nuanced problems that you get with like client configuration across multiple apps in a distributed system. Cool. Okay, so I think we will do a quick demo now of Linkerd and gRPC, and then we'll have a little bit of time for questions. Cool. Okay, so this demo is available on my GitHub. If you want to see it, it's pretty simple. We have a app that we created, a single Kubernetes manifest, which I'll go through, but basically it spawns 4 deployments. One is a traffic generator, which sends HTTP 1.1 requests to a gateway application, and then the gateway fans that out to 2 backends, and one backend is REST, and one is gRPC. And we sort of leverage some fun open source projects to build it. Okay, so let's see. All right, so I have a Kubernetes cluster running here, and it is already running Linkerd. Let me bump the font real quick. Yeah. Okay, let me just make sure Linkerd control plane is up and running. And it is. Maybe I'll go a little bigger even. Cool. All right. So in this directory, I have an app file, app.yaml, and this is sort of should look like standard Kubernetes services and deployments. They're not really doing anything special. But so here's the REST backend. We have a service in front of it and a deployment. This deployment has an annotation on it that says linkerd.io/inject enabled, which means that this deployment will pick up the proxy when we apply it to the Kubernetes cluster. That's the REST backend. Same goes for the gRPC backend. And then the gateway application and the traffic application are not inject enabled. So when we initially apply this configuration, the two backends will be injected with Linkerd. The gateway and the traffic service will not. So let's go ahead and do that. That'll create all of our objects. Have a look in the default cluster. So these are initializing. And I can actually run a Linkerd check -- proxy, which will wait for everything to come up for me. But basically, this checks to make sure all the pods are up. And Linkerd uses an admission controller, a mutating webhook, to actually do the proxy injection. So it's watching all pod creates, and when the pod with the annotation shows up, it will add the proxy for you automatically, and it should be all set. OK, so then we can start getting stats from the injected deployments right away. So we can run Linkerd stat deploy. And you can see that, so the gateway and the traffic service are unmeshed in this view. Actually, I can bump it just a little bit more even. There we go. So gateway and traffic are unmeshed, but gRPC backend and REST are meshed. They're both at 100% success rate. All these stats are coming from the Linkerd proxy. Like the apps themselves are not instrumented to export any data, but the proxies are routing the traffic, and so that's how we are able to collect it. You can see, and then you can see sort of golden metrics for all of the deployments. So you get their requests per second, latency, percentiles, and the number of TCP connections. And you can see that the gRPC backend is much more efficient on TCP connections. But if we look at the individual pods in each of the backends, that needs to get a little smaller. So this is exactly the load balancing problem that we were talking about, right? So the REST traffic is being sort of evenly distributed across all three of the REST backends, but the gRPC backend, only a single replica is receiving all of the traffic. Basically, when you use the default load balancing strategy in Kubernetes, it's connection level load balancing, and you're going to end up in this situation. So there's a couple workarounds. Actually, there's another talk later today about gRPC load balancing too, but I think Linkerd is a really elegant solution for this. So we just add Linkerd to the gateway deployment, the client of the gRPC service. That should start balancing traffic right away. So let's go ahead and do that. Actually, kubectl get deploy gateway. -o YAML, and then I'll pipe that to Linkerd inject in order to add the proxy annotation, and then I will apply it back to my cluster. There we go. And so now the deployment, if we look at all the pods, we'll see that there's a new injected gateway pod coming up that has 2 containers in it, and the old one will be shut down momentarily. And then right away, I think we should be able to start seeing the change in traffic. Let me just shorten the time window on this. Yeah, there we go. So now the gRPC backend is fully load balanced, and the traffic is a lot more even. And still, the number of TCP connections is really low for the gRPC services, so it's much more efficient there. Cool, and then we can sort of take advantage of a bunch of other Linkerd features to help inspect the traffic that's going on. So there's a feature called tap, which will actually tap into one of the proxies and get a sampling of the request that it's routing, and then that way you can get individual request data to sort of debug issues. So we could say tap one of the backend deployments, so Linkerd tap deploy / gRPC backend. And this will dump a bunch of data out. But you can get this in different formats. But basically, you can see the source and destination IP, the method that's being called, the endpoint, that kind of thing. And then and there's a lot of other CLI functionality, but Linkerd also has a dashboard that you can access as well. So let's pull that up. And there was a lightning talk about the dashboard on Monday. I'll bump the font up here a little bit. And basically, the CLI is fully featured, has all the data you need. The dashboard really lets us tell like a better narrative about like what's happening within your services. So it's another useful view. Let me go slightly larger. Cool. So this is the sort of same thing we were seeing on the command line. But if I click into one of these, then I can see kind of the upstreams and downstream deployments, and then all the live request data right here. This is a sample gRPC app, so we only have one endpoint, that kind of thing. And then we also have built-in Grafana dashboards for all of the Kubernetes pod owner types, like deployments, stateful sets, replica sets, that kind of thing. So if I just click on this Grafana link, that will bring up a dashboard, and it has sort of all the stats again. Good visibility, one end-to-end deployment. And then the other thing to note on this graph is that prior to injecting the gateway deployment, the traffic between the gateway and the gRPC backend was not TLS'd. And you can sort of see it with there's no lock symbol for the yellow line there. But as soon as we injected the gateway, when traffic resumed, we ended up TLSing all the traffic on the connection too. So without making any changes to the application, we were able to encrypt the traffic as long as there's a proxy on either side of the client-server connection. Yeah, and then I think that's about it for the front end. Yeah. Oop. I'm going to come back here. No, here. Here we go. So just quick recap. If you try the demo out, there's also service profiles in the demo. It would take a while to demo it, but you can actually use the protobuf definition to create a service profile for the gRPC backend and then start playing around with its client policy, and I recommend you try that. But yeah, so that's about it for the Linkerd portion. Let me come here, and I think we have a little bit of time for questions. Should we do that? Cool. I can maybe run the mic around, or you need a mic? Oh yeah. Oh yeah. All right. Cool.
Okay.
Thanks.
Okay. Who's first? This guy. I'll run about.
Yeah, from what I saw about the stats you printed, I was quite surprised to see that the gRPC backends had higher latencies than the REST backends. Is this
Yeah, I actually was wondering about that too. I think it's actually more a consequence of running on my laptop. I think it's sort of resource contention that's happening. If I was actually going to benchmark the two protocols, I would do it on a dedicated cluster to get more accurate.
Did you benchmark in your production settings when switching to gRPC?
That's a good question for Ben. Did you all run any benchmarks on REST versus gRPC?
Yes, we did. But I don't have the stats to hand. I don't know. But we found it way quicker though. Like gRPC, the overhead. Sorry, the overhead of the connections for us were the biggest drain. Like we saw that it wasn't just the latencies that were slow. It's like the entire, even stuff that wasn't done over the wire, like from the GraphQL point of view, that whole came to a halt too. Like the amount of memory that the entire pod was using was ridiculous. But then switching to gRPC was much quicker. We did have a small issue with serialization of the data, but I think they fixed that in a different version of gRPC. Yeah. Who's next? Cool.
Yeah, thank you for the talk. It's no doubt Linkerd is adding a lot, but you said that you had this problem with gRPC load balancing. Have you tried different client load balancing policies that would even the load? That's a second question. What version of the Linkerd are you showing? Is it 2, I guess, right?
Yes,
it's
it's Linkerd 2. Yep.
So for the first question was, have we tried client-side load balancing? I was not really aware of stuff at that point with client-side load balancing. I know I met a few guys last night that are doing a talk today about client-side load balancing in Kubernetes. I will be going to that, but we didn't look at that now.
Yep. There's one over there. I can run it if you want.
I'll run around. This is a good exercise.
Okay.
So what did you do to automatically switch that client application from connecting directly to connecting via the Linkerd proxy? How did it automatically switch?
So as part of the injection process, we add the proxy container into the pod spec. We also add an init container, and the init container runs before the pod initializes, and it rewrites the IP tables rules of the pod so that all inbound and outbound TCP traffic go through a port on the Linkerd router running in the pod. There's one back there. Do you want me to?
Yeah, I'll let you do it. I'm out of breath.
Yeah.
So, 2 questions. First, do I need to have an ingress in front of my service or not? The second one, if I have my gRPC service and I expose it on a node port, I want to do my own load balancer, I don't know, HA proxy or whatever. Can I target, like, as a proper load balancer, all the nodes where this gRPC is running? So basically, like, does it work through the ingress? And does it work if I implement my own load balancer as a certain node port?
Sure. Yeah, so the question was, will it work if you're using ingress, and will it work if you have your own load balancer? And it should, Linkerd does not provide an ingress, so you would use one of the existing Kubernetes ingress to get, sorry, oh yeah, 2 mics. Yeah, there we go. Yeah, so you would use one of the existing Kubernetes ingress controllers to get traffic into your cluster. Nginx works just fine. And then if you have your own load balancer, it really, I think the main takeaway is that you need request level load balancing for gRPC. If you're doing connection level load balancing, there's just not enough new connections created to actually successfully balance across all your backends.
A few more here.
Yeah. Maybe if folks want to come up with questions too, feel free. I can keep running back. But.
Hi there. Question around the request streams. Have you had any experience with leaving request streams or response streams open for very long periods of time, like hours or even days? Because I know you can just do a simple request response, but then you can also reply with a stream, can't you?
Yep, that's right. So yeah, with gRPC you can have long-lived streams, and you can have bidirectional streams as well, and that all works just fine. I mean, Linkerd will keep the connections open as long as they're in use. Did you all use any of the streaming APIs?
We did not, no. No, we didn't use any of the stream stuff in gRPC.
Yeah. But yeah, they're really powerful. And yeah, I've seen, most of the use I've seen is for like streaming data back, from the client to the server. That kind of thing, and it is very seamless. The other thing I like about gRPC is since it uses protobuf, you end up with language-specific bindings. So when you're working with the gRPC clients and servers, they feel really natural in whatever language you're working in. So the Go implementation or whatever of streaming is really straightforward to work on.
Sure. Sorry, I want to.
Thank you. 2 questions about observability. So I saw in the architecture diagram that you have a Prometheus instance, which I assume is the one that's also telling to the CLI latencies and all the other things. Would you suggest to run a separate Prometheus instance and then pull metrics from that one, or doing it another way? Second question, you're pulling out some requests. Has that anything to do with tracing, and does Linkerd support tracing and how?
Yep, 2 good questions. So the first one was about running your own observability stack. My recommendation is to scrape the Linkerd Prometheus. You can use Prometheus Federation. Linkerd's Prometheus is tuned for very short-lived data because it's sort of for real-time diagnostics. So typically folks would, and it really won't take that many resources in your cluster anyway, so typically folks will just federate that Prometheus or set up a scrape config to scrape all the proxies, because the proxies are all labeled already for that. And then your second question was about tracing. Yeah, so we have the tap feature to dump live requests. We're also able to draw service graphs using metrics data from Prometheus, but we don't have support for tracing right now. It's definitely on the roadmap. I think the thing that has been difficult getting tracing implemented is that it requires participation from the applications themselves to not break the trace. And one of the sort of ideals behind service mesh is that the application should kind of not know that they are running in this mesh environment, right? They should be sort of kind of totally ignorant of the fact that all this magic is happening around them. And I think tracing breaks that model a little bit. So we haven't quite figured out how to do it. Yeah.
Next one here.
Hello, quick question about having multiple services in Kubernetes connecting to the same workloads. So now in your model, you can have one service pointing to, say, one deployment. And I was wondering if you ran into that issue that it's possible to have multiple services pointing to the same multiple workloads, and if Linkerd dashboard or the service graph you were talking about handles that in a specific way, and is that an issue even for you or not really?
No, I mean, I think most of the stats that you see in the dashboard are reported from the pod, the inbound Linkerd on the pod that's receiving the traffic. So the backend pod would just be reporting all the traffics receiving regardless of which service it's coming from, but you can also look at the outbound stats for the routers that are sending the traffic, and then that way you could slice it up by the services that they're going to. Yeah, so I think it all just works in that way, yeah.
Yeah, I think we have time for one more, maybe.
Yep.
Yeah.
Thank you for the presentation. My question is about the protocol buffer publish mechanism and kind of things. Have you tried another alternative like have a single monorepo for all the proto buffers in your organization and try in this way to share the versions and how to manage the versions and kind of things? Can you explain a little more about why you are doing the things that?
Yeah, okay, so the protobuf management is kind of still a topic that everyone talks about. Putting things in monorepos makes more sense, I guess, because everything's contained in one repo. We never did that. We started off with everything was in a lot of different repositories, and that brings a lot of problems with boilerplate and everything else to like create new repositories. We never played about with the monorepo thing, so I'm not sure if that's better or worse than the solution that we came up with. Like I said earlier, our solution was to publish to the native package manager. The reason we put the protobuf with the actual repository itself is because although they were in the same repository, they were deployed as two separate artifacts. So you'd have the main app, which was built as a Docker container, and then the actual protobuf schema was then built with the same version, but then pushed to the package manager. So they were still coupled with the same version, so you still had one version for both artifacts, but they were separate. I'm not sure if that answers your question or not. But we didn't really look at monorepos so much. Yeah, there's a lot about it. Yeah. Yeah, it's quite a big pain point.
Yep. Cool. I think
that's everything. Thank you very much.
Really good. Yeah, thank you for coming. Really appreciate it.
Awesome.
Nice work.